Hey everybody, so we're going to continue with our tutorials on fractional distillation on our virtual lab here. So I'm going to move to document number 2. So again, you can access documents 1, 2, and 3 on Canvas. This is document 2 here. So the first portion shows us what's referred to as this Williamson microscale glassware kit. They're identified with letters A through V, and what the pieces are listed over here on the right. We're going to be utilizing things like it's already circled here, like our round bottom flasks and our distillation head right there. So when you're kind of putting together an image of this setup, you can reference these items. So I'm going to go through this document fairly quickly. So this will be a rather short video, but we can see another kind of distillation that was performed here between butanol and cyclohexane. So this is another example of a mixture distillation. It includes some theory behind this process, some keywords, some key equations here that are also referenced in your chapter 5, fractional distillation from the lab manual. So all of these things are kind of included on this document in one place here in a shorter document than your lab manual. So any of this information, if you'd like to reference it or ask questions, please let me know. These just show here our fractional distillation versus a simple distillation. So notice that the column is added when we have this fractional distillation to ensure that we have more of these theoretical plates that you might have read about in your lab manual to provide this fractionation as we do our distillation. So we actually can separate a mixture or components in a mixture that have closer boiling points than we would be able to with a simple distillation. So there are some requirements for each type. And usually, when we perform any type of distillation, you would have this ice bath receiver or this ice surrounding your collection vial to prevent any of your volatile compounds going back into vapor phase. So once they're distilled, you want to keep them liquid. So again, this shows another kind of virtual type of or simulated distillation information, including 2 different drops versus distillate. So we have our temperature and then the volume or number of drops here shown. So we'll reference our data on document 3, our post-lab document. But in case you want to check out this distillation as well, even the analysis using a gas chromatogram, our gas chromatograph is shown here, kind of the schematic. So we usually use a carrier gas if we use a fancier, more expensive GC unit. But the units that are referenced in the video in document 1, those actually use room air as our carrier gas. So we would inject our specimen, it would pass through the column, it would be heated, depending on its retention time, it would hit the detector. Each component would hit the detector at different times. So again, we're going to solve or identify from our data, our graphs, what our retention times are. More theory, more background about the process, different types of gas chromatography that can be done, and then be thankful we don't have to do this mathy calculation. The software and the analysis, the Logger Pro software and the analysis has actually already been done for you. But if we had to calculate an area, we would, by hand, we would use this formula. So here we go. These are sample calculations of a mixture with 4 components. So you can reference this if you like when you're doing your own calculations for the post lab, but I will show you a sample calculation with only 2 components in a third video. But your response factor here, this is going to be calculated. This has to do with how each component responds based on a standard using the gas chromatograph. So we're going to look how to calculate this in addition to finding the retention times. But the areas, those have already been calculated for you. So again, these are just sample calculations for a mixture of four components, but I will walk you through this same type of calculation and data analysis in our third video.